Okay, this video is a quick demonstration of some progress with the Pocket Computer Universal Interface, and this is a device that I started creating and working on really to address, those in the hobby of collecting these old pocket computers or, having any interest in them at all. Sometimes it's hard to find the printers, and sometimes if you can find the printers, the pens and or the paper that it may take is hard to find, in the case of like the aluminum coated paper, for example. But anyway, this is a PC-8 from Tandy, and this is really made by Sharp. So this is really a Sharp PC-12xx, I believe. And while I do have the printer for this, which is here, and the cassette interface, so this lets you print and save programs to tape, they're still hard to find. But anyway, this PCUI, or Pocket Computer Universal Interface, is designed to interface with various models of pocket computers and graphing calculators and provide a interface to standard or more standard readily available printers, and to also emulate cassette storage. So the way this works is you would plug in your pocket computer or graphing calculator. There's a TI port here for TI graphing calculators, and that is already working. I posted some videos on that working. But there's another interface point here for pocket computers, or those that have more of a bus interface. This TI interface is just a 3-pin serial type handshake, far easier to get working. So the idea is the PCUI can interface with Sharp, Casio, various models through a standard connector, and then you use like what we call an interface pack. And the interface pack would vary depending on the particular model of pocket computer. So in this case, we're using the 11-pin Sharp as an example. And this is a very early prototype, so by the time this video is posted, there will be a readily available, more more stable form of a connector here. So for now, I'm using my Casio interface pack into a breadboard and then just rewiring everything for the Sharp model here. So on the main screen, the PCUI, the interface is a very small OLED screen. Again, just to serve the purpose of a menu, both to select the model of pocket computer and then to operate some of the functions. So for example, and the refresh rate on this is somewhat interfering with the camera. I haven't figured that out yet, the scan rate there. But anyway, you have settings. We can enable the printer mode, and we can send a program or send variables. So for example, if I enable printer mode, what'll happen is it'll indicate the printer mode is enabled. So now what it's doing is it's monitoring the bus for commands or data to select the printer, and or once that's done, sending over the bits of data for the actual printout. So for example, in this particular model, if I hit Shift Enter, it'll turn on the printer echo, and you can see that little P icon hopefully there on the top. And then if I type something in here like 4 times 9, in theory, that'll start printing to the printer. So I can then divide that by 5, and then maybe divide it again by 2. And then if I go over to this printer, this is similar to how the original printer would have printed. Looks like we have a little bit of a glitch there on the output. Probably something to do with this wiring. Anyhow, so that's the idea, so that it'll emulate that printer. Now this particular printer is anywhere from this style of printer. These are Epson thermal printers, receipt printers, and they can be had for anywhere between $20 and $40 roughly. And they're widely available, very inexpensive. This is a serial printer. I have a parallel version of one of these, and on the PCUI you just select what type of printer you'd like to use, serial or parallel. So you could use an old dot matrix printer, for example. So the printer echo is one mode of this. You could also have a program which I've demonstrated often, the banner program, for example. So what I could do is I could print a banner, say ABC, and then that output will then be directed to this printer via the PCUI. And again, this isn't anything different than this printer, except that this is far cheaper and far easier to get these days. So the printout would be very much similar, and the printer width is still limited to, I believe it's 24 characters, because this printer was 24 characters, and the PC-8 outputs a row of 24 and then a carriage return there. So this is, again, very early prototype here. It does work, and once I clean up this wiring and actually get a proper interface pack made up for this particular model, it should eliminate a little of that spurious characters on occasion there. So one thing to note, this PC-8, or PC-12xx as Sharp would have had it labeled, is actually older than the PC-3, which is also using the 11-pin connector. So this also works with the PC-3. So that's a PC-1250 from Sharp, I believe. And maybe there's a 1250A or 1251, I can't recall, that had more memory. But anyway, the 11-pin connector support on the PCUI does add quite a few more models. So let me just show another example of what the PCUI can do. So that's printer mode, and we'd have to shut that printer mode off to use some of the other capabilities. So for example, if I wanted to write a program to, let's say I go in here and I want to show an example of sending a program, what I can do is click, I'll type, I'll go into program mode, I'll enter new to clear out the banner program. I'll just say 10, print, and we'll do hello world. This is not the best keyboard to type on. Okay, so there's a program, hello world, and what I'm going to do is save that to SD card. The PCUI is always listening for cassette data coming from the attached pocket computer, so in this case I don't have to put it in a special mode to receive anything. So I could just type C save, and I'm going to give it a file name here of test. And then the screen will go blank, the busy indicator will be on. It's a small program, so it won't take that much time. And it's done. So if I go here, and this menu system isn't fully baked yet, but if I go to send program, you can see, hopefully, test is at the last, it's alphabetical. So I have banner, I have a hello world, and I have test at the very end. So to prove that I can send and receive, as I was testing this, I'm going to type new, so clear out that program, and to prove that that program is not there, I'll hit list, and there's nothing there. So what I could do is C load. I could type test as well, but if you type C load or cassette load without a file name, it will load whatever you send it. So I'll go ahead and do that. And then I will scroll down to the test program here and click the OK button. And within a few seconds, you'll see an asterisk appear on the screen. That's just indicating that receive mode is passed, the checksum at the file name and all that is passed. The loading's done. It's a very small program. So if I type list, we then have our hello world program in there. And the same thing works on variables. So you can do a print £. That'll save all the variables to cassette. And then likewise input £, would load variables from cassette. And so that's what the send vars option would do. So you can send to variables that way as well. And the storage is actually on micro SD. And then each one of the pocket computers has a subfolder automatically on that SD card. So if you want to take the card out, you can just remove the card, and each Pocket computer has its own folder for the programs. And one thing to mention also is, as I was testing this, and this does not require a computer or a PC at all. And one thing that is helpful, though, if you do have this attached to a PC, so I have the USB port on this connected to my PC, I can go into the settings and then go down to SD card or micro SD, and then I can turn on what's called USB drive mode. And what that'll do is expose the SD card through software to make it appear as a removable drive in Windows or on a Mac. So that lets you pull your programs off or your data off of the SD card without removing it from the PCUI, which is helpful. So you can, if you have your program stored somewhere else, you could drop them on the SD card here through your PC, and then you can stop the transfer, and then you'll have the files available to you in the menu system here. So that is it. That is the first working prototype for this particular Sharp model. Casio is one of the others that I'm working with now, to those models that have a 12-pin connector. Very similar, but different in some ways. So that support is being worked on. It's a little bit further along than this one is because I already have an interface pack for Casio. I'm going to make one for Sharp for this model as well. And then the Texas Instruments support has already been done, as probably one of the first POCs that is working. So the intent of this, again, is to be used portable without any computer, so that's why there's a battery here. I'm debugging currently, so that's why I'm providing power through this, just because I don't yet have a charger circuit on here for that. And it's all based on a Raspberry Pi Pico, and you can see my debug cable is there. And then this is, I only had these connectors hanging around, so this is actually the wrong interface type here. And so I'm going through an adapter and the null modem cable. So there's another revision of this board. I just didn't want to waste this. This board has been used through several iterations of design here, so it's tough to let it go, but I don't want to have to solder everything too many times for test boards. So this one's been through quite a bit. And then I'm using another Pico here to debug. These are very inexpensive, so they work out well for this project. So the idea is this is intended to be used completely portable. If you wanted to, no PC needed. You can power it by USB or a 18650 rechargeable battery, and it provides the standard parallel or serial port out to printers. So that's what it's intended to do for the printer interface. And then I did mention cassette would be stored and loaded from the micro SD card. So the idea, again, just to run through the models, Sharp, Casio, TI graphing calculators, that's kind of the initial phase of this. Eventually, I'd like to get this to work with some of the very old Casios, like the 702P, if I'm not mistaken. It has I guess a spark printer with aluminum paper. So not only is a printer hard to find, but the paper's very hard to find. So it'd be nice to get this working with that, because again, even though I have some aluminum coated paper, they don't make that anymore. And if they do, it would be for very old devices and very hard to get. So that's the intent of this interface. So I'll be posting more videos about this progress, so stay tuned for that. And I'll put a description of the link to the project in the description. So if you want to follow along with a post with more detailed information on this project. This is intended to be something that you can build yourself. So I plan to offer this as a kit so that you can effectively put it together, and then hopefully it'll be a little bit easier to the intent is for it to be easier to find, obviously, than these printers are, but also not at a extremely high price. So we're trying to keep the component cost down, hence the Pico, very inexpensive LCD or OLED screens, that kind of thing. And then the connector, this is always a challenge, as we all know. Trying to find these connectors for these pocket computers is tough. So I'm getting creative with the PCB design and some of the header pins and things like that. So that's always a challenge. But anyway, stay tuned for more updates as progress is made and more models are supported. And check back often.